This call is now being recorded. Okay, once again, good afternoon. Before we're going to proceed, let's have some review. This is now with regards to having a bivariate random variable and then finding the probability distribution function of a bivariate random variable for a continuous case. So we have here a random vector xy having a continuous random vector is a continuous random vector with a PDF. Okay, we have here the PDF, small f sub big X and big Y. And then to be able to determine the joint PDF of a new random variable, a new random vector UV, it can be expressed in terms of the joint PDF of X and Y. But first we have this set, script A, which is actually the set of all XY such that the joint PDF of XY to be positive. And then script B here should be the set of all ordered pair UV. So these are the realized value of our random vector UV such that U is equal to G sub 1 of XY and then V is equal to G sub 2 of XY. That is for some XY in the script A, the set script A. So if we're going to assume that we have a one-to-one transformation from one-to-one transformation from script A to script onto script B, then we can find the inverse function or the inverse transformation by having X here to be the function H sub 1 of UV and then Y to be the function H sub 2 of UV. So after determining these sets, script A and then script B, and then after determining also if we have a transformation, a one-to-one transformation from script A onto script B, hence we can able to determine the inverse transformation. And after that, determine also the Jacobian of the transformation denoted by capital letter J. And this is actually the determinant of the matrix of the partial derivatives. Okay, since we have only have a 2 by 2 matrix, so it's easy to determine the determinant of this matrix of partial derivatives. Hence, the joint probability distribution function of UV can now be expressed in terms of the joint probability distribution function of XY here, in equation 4.3.2 times times the absolute value of the Jacobian of our transformation. Actually, we stop at this particular example here. Say we have the distribution of the product of the beta variables, X having a beta, alpha beta, and then Y has a beta, alpha plus beta, and then gamma distributions. And these are independent random variables. If we're going to determine the joint PDF of X and Y, okay, since these two random variables are independent, we have the product of their marginal probability distribution function. So for the first random variable X, we have here, okay, and then if we're going to simplify further this product of PDF, we have here in our blue expression, we cancel out the gamma of alpha plus beta and then in the X variable and then gamma plus alpha plus beta in the denominator of the random variable Y. Okay, I modify the problem in the book. So we have here at the bottom, we let X here having a beta, alpha beta distribution, Y beta, alpha plus beta gamma distribution, and these are independent random variables. Then we define U here to be the product XY and then V to be equal to X. Okay. First, we're going to find the joint distribution of X and Y. We are done with that. And then letter B, we're going to find the joint distribution of U and V. Okay, so we have now our transformation. U is equal to XY and then v is equal to xy. So the set of possible values of v here is between 0 and 1 exclusive, since we have v to be equal to x. So for any fixed value of v to be equal to small v, then the value of our random variable u must be between u and v, since we know that x is equal to v, and then the value of y is between 0 and 1. Okay? And so the first thing that we need to do is to determine these two sets. So script A here is a set of all ordered pair xy such that the joint PDF of xy is positive. And then the value of y, x and y here is between 0 and 1 exclusive. And then the script B, according to our definition, it is the set of all ordered pair u, v such that we have the transformation. So u is equal to xy, and then we have v is equal to x. That is for some. Take note, that is for some xy, ordered pair xy in script A. And then we know that the value now for u to be greater than 0, but u is less than v, and then v is less than 1. So we have here our transformation. U is equal to xy, v is equal to x. If and only if, we can now determine or express y in terms of u and v. So y is equal to u over v, and then x is equal to v. By this biconditional statement, it implies, no? This implies, pwede naman natin lagyan yan. We have here the implication that we have a one-to-one. Okay, we have a one-to-one transformation from script A onto script B. Okay, a one-to-one transformation. So in other words, our inverse function now, we have here, no? This x in terms of the function u and v, and then this y is in terms of the function, it's a function in terms of u and v. Okay, so since it's a one-to-one transformation from script A onto script B, then we can use our formula in the preceding discussion. So we're going to find the Jacobian of our transformation. It's actually the determinant of the matrix of the partial derivatives. So take first the partial derivative of x with respect to u is 0. The partial derivative of x with respect to v is equal to 1. The partial derivative of y with respect to u, we have 1 over v. That's so. And then the partial derivative of y with respect to v, we have negative u over v squared. So it's easy to verify that one. And therefore, our Jacobian of our transformation, we have this determinant of the matrix of partial derivatives. We have the value negative 1 over v. Therefore, the joint PDF of u and v will be equal to this product, which is the joint PDF of x and y, in which we evaluate it on the values of x, which is equal to v, and then y, which is equal to u over v, times the absolute value of the Jacobian of our transformation. And then we have the value for u must be greater than 0 but less than v, and then v must less than 1. And then using the PDF, okay, of our x and y, but we replace the realized value of x and y in terms of u and v. So we have this. Yung nagkamali ako last meeting, itong expression sa 4.3.3 is actually this expression now, no? Kani siya nga part. Okay, mao ang result. So I further simplify it. Say we multiply, no? We multiply by 1, which is actually an expression u over u, itong part na to. And then after that, we simplify, and then we cancel, simplify the expressions, and then we cancel the common factors or factor. Say this one, v alpha over v alpha minus 1, that is v alpha over v. And then this expression also here can be expressed nasa green, and we can cancel out now v alpha. Okay, so U ni siya. Tama na ni siya nga U. Because last I thought it's a V. Uh, okay, so that's U. So this is now the joint, the joint PDF of U and V. So that's the second problem. Okay, ang third problem, find the marginal distribution of V. Okay, since V is equal to X, and X has a alpha beta distribution, clearly our V also has a alpha beta distribution. That's for letter C. What about for the marginal distribution of U for problem letter D? Okay, for problem letter D. So for problem letter D, so determining now the marginal distribution of U. It says here it has also a beta distribution, but we're going to verify it. So from our definition, the marginal PDF of U is equal to, it's equal to the improper integral. Okay, that's the improper integral of our PDF of U and V dV. Since the value of V here is between 0 and 1, kaya yung limits of integration will now be since since V is greater than U but less than 1, so the limits of integration now will be from U to positive 1. Okay, so yung value ng U natin dito would be between 0 and 1. That's clear for that. Okay, so we just substitute our joint PDF of U and V. We write the terms that does not depend on dV before the integral sign. So ito yon, pinalabas na natin. Kung titingnan natin yan sa itaas, itong part na to. Ibahin na natin yung kulay, itong part na to. Okay, sinimplify natin. Okay, so yung maiiwan as an integrand, we have that. Okay, so if we're going to distribute here U times 1 over V, so we have U over V, ito yon. And then V will cancel out, so we have U. Ito yan, so beta to the 1. And then we have here the next factor in our integrand, and then we have U over V squared. Kaya sinimplify ko na lang, no? Yun sa PDF natin ng sa U and V. So we have that. Okay, so to be able to integrate the expression in our marginal distribution of U here, we're going to change variable. So we let Y here, itong Y natin, be equal to, pwede yan, no? Sabihin natin na U over V minus U. And then divided by 1 minus U. That is our Y. Okay? Or we have 1 over 1 minus U. And then we have here times U V to the negative 1 minus U. Then if we're going to take the derivative of Y with respect to V, so meron tayong dy dV with respect to V. So we have here 1 over 1 minus U. And then for our other factor, so negative 1 U V to the negative 2. So meron tayong negative U over V squared. Okay, so the dy now the differential of y now will be just equal to this. Okay? Yung nasa itaas, dy is now equal to the negative u over the quantity. We have the product v squared times 1 minus u dv times the differential of v. Okay? So, simplifying. Again, if we let v here to be equal to u, if v is equal to u, then the value of y here will be equal to if v is equal to u, then the value of y is 1. Okay? If v here then y will be equal to 1. If v will be equal to 1, then y will be equal to 0. Take note, itong u nasa lower limit of our integration. Yung 1 natin nasa upper limit of integration. Pero pag tiningnan natin dito, yung y is equal to 0 because we changed variable in the limits of integration, and then y here is equal to, the upper limit of integration is equal to 1. It's because of this negative value here. Itong negative value dito. Okay? Say for example, the integral of f of x dx, negative f of x dx evaluated from a to b. That is actually equal to the integral of f of x dx evaluated from b to a. We have that as one of the property of integral. We have learned that in calculus. Okay, so again, simplifying all the more this, yung part niyan, yun lang ang in-emphasize ko, yung limits of integration dyan, and then you can also verify itong second part, itong part na to, because this is, we take this as our y here. Itong part na to, we can simply subtract or add u in that, say we have here 1 minus uv, then we have here minus u plus u. This is the same as 1 minus u quantity, then minus we have u over v minus u. Again, all the more you're going to simplify that until we'll be able to get this integrand now. Okay? So the integrand in our integral is actually the kernel of a beta distribution with parameter. Okay? It's a kernel of the beta distribution with parameter beta and gamma. And that is why using also the property of our PDF, because it's a PDF of a beta distribution, that would sum to 1. Therefore, the resulting expression here will be just equal to this. So we have gamma of beta times gamma of alpha over gamma plus beta alpha. Again, simplifying, we can cancel this. Oh no. Then we have that. And then if we're going to notice the distribution of our marginal distribution of u, it has a beta distribution with parameter alpha and beta plus gamma. Okay, so that's the marginal distribution of u. Okay, let's have another example to illustrate further what we been discussing about this bivariate random vector. So suppose we have a sum and difference of normal variables. Let x and y be independent, standard normal random variables. Then consider the transformation u, which is equal to x plus y, and then v is equal to x minus y. Okay, in the notation above, we let u here Since we're using x and y, so for the new random variable, we're using u and v. So u will be a function g sub 1 of xy, and then v is also a function of xy, g sub 2 of xy. So we have that. Letter A, find the joint distribution of x and y. Letter B, find the joint distribution of u and v. And then letter C, find the marginal distribution of v, and find the marginal distribution of u. Okay, since these two random variables x, y are independent, then the joint PDF will just be equal to this, the product of their marginal PDF. So possibly dito muna, so that is times f of y. And then we have that 1 over the square root of 2 pi, and then the exponential function of the negative x squared over 2. And then 1 over the square root of 2 pi, independent, exponential, the negative of y squared over 2. And then now we have here the support of our random variable x and y. In other words, this is the sample space of the random variables x and y. And then to simplify, we have that above. So we have now 2 pi to the negative 1. Okay? Or pwede na lang sabihin natin, this is equal to 1 over 2 pi. So we have the exponential function of negative x squared over 2, and then exponential function of negative y squared over 2. Again, the support for our random variable x and y. Okay, so that's the answer for letter A problem. What about for the letter B problem? We have u and v. We have the transformation already, no? U is equal to x plus y, and then v is equal to x minus y. Okay, so before that, we're going to determine our set script A. So ano yung set script A natin? It is the set of all ordered pair x, y such that the joint, yung joint natin is positive. Okay, x here to be negative infinite, and then y. Then what about our script B? It is the set of all ordered pair u, v such that our u here is equal to x plus y, and then v is equal to x minus y. This is for some ordered pair xy element of script A. It's according to our definition. Now we have this transformation. Now the transformation we have here u is equal to x plus y, v is equal to x minus y. This would imply that our, okay, pwede naman siya ma-simplify natin further. We have now the x would be equal to u plus v. Pwede nyo verify further, no? Over 2, and then y here to be equal to u minus v over 2. Okay? Since for each uv, ordered pair uv in script B, there exists only one ordered pair xy in script A. Now that satisfies this transformation. So this implies that we have a one-to-one transformation from A onto script B. So ang implication nito, so we have a one-to-one transformation from script A onto script B. Okay? Hence, this x here, itong x dito, ito yung the inverse function as a function of u and v, and then y is also the inverse function as a function of u and v. So since we have a one-to-one transformation from script A onto script B, now we're going to determine our uh, Jacobian of our transformation, taking the partial derivatives. Okay? Uh, okay, so pwede natin. And now the partial derivative of x with respect to u here, with respect to u, okay, so the answer would be equal to 1 half. Partial derivative of x with respect to v, the answer is also equal to 1 half. The partial derivative of y with respect to u, okay, the answer is equal to 1 half. The partial derivative of y with respect to v, we have negative 1 half. Thus, the Jacobian of our transformation is the determinant of the matrix of the partial derivatives. Matrix of the partial derivatives. We have 1 half times 1 half, 1 half, 1 half, 1 half, negative 1 half. So we have here negative 1/4 minus negative minus plus 1. Okay. So the answer is negative 2/4. So we have here negative 1 half. Okay. Implies. Ganun na lang natin. Okay. So implies G. Thus, we're looking for the joint distribution of U and V. So the joint PDF of U and V, we have U, V here. By definition, we have here X, Y, and then our U. Okay. X should be in terms of U plus V over 2, and then Y, U minus V over 2 times the absolute value of our Jacobian. Okay. So we have 1 over 2 pi using the joint PDF of x and y times what? We have here the exponential function u square, okay, the negative of x square. So we have here u plus v quantity square, 2 square. So we have 4. Then may over 2 pa naman tayo. So times 2. And then we have here the exponential function, the negative of u minus v quantity square, then 2 square, that is 4 times 2. And then the absolute value of the Jacobian of the transformation, we have here positive 1 half. Okay, so we are making a transformation from x to y. So our u here from negative infinity to positive infinity. Same thing with v, from negative infinity to positive infinity. Okay, then expanding. So we have negative u square plus 2uv plus a v square over 4 times 2. Then the exponential negative of u square minus 2uv plus v square over 4 times 2 times 1 half. So you copy pa rin, no? Dito ko na yung sulat, no? u, v greater than negative less than infinity. Okay, so simplifying. We have the exponential function. We can have the exponential of the sum of this. If we're going to distribute the negative, no, from our expression in our exponential function, we have negative u square, negative 2uv, minus v square. Then we have also negative u square on the other exponential function. Then we have positive. So mag-cancel out yung the sum would be 0. The negative 2uv and the positive 2uv, that would be equal to 0. So yung result na yan will just be 1 over 2 pi. We have here the exponential. Okay, we get the exponential of the sum. What happened here? Oh, okay lang pala. So we have here negative u square 2. Okay, 2u square. Sorry, 2u square. And then we have also minus 2v square. Four times 2, pwede yan 4 times 2. 1/2, 1/2. Okay, so this one. And then we can write this as 1 over square root of 2 pi. And then we have here the exponential negative we can write also square root of 2 here. U square over 4. Okay, UV infinity. Okay, so that's the joint PDF of our new random vector of random variables u and v. Since it's a product of a function of u and a product of a function of v, this would also imply here that u and v are independent. Okay, so we're done with problem letter A, and then problem letter B. Again, this example 4.3.4 in the book, I modify it in such a way na mas klaro yung required in this particular example. So I'm going to give this as your additional problem in your problem set. PS. For that. Find the marginal distribution of V. Find the marginal distribution of U. You have already the joint probability distribution function of U and V. Okay, so I think you can do that. Okay, theorem 4.3.5, that x and y be independent random variables, that g of x be function only of x, and h of y be a function only of y. Then the random variable u, which is equal to g of x, and v, which is equal to h of y. Pag ganun yun, will also be, these two are also independent. Parang may kulang yata tayo na problem. We do not have a problem if the transformation is not one-to-one and onto, because the two problems that we have, those are transformations in which we have a one-to-one and onto transformation. So kulang itong PDF ko. So tingnan na muna natin yun. Tingnan ito. Okay. Supposing the transformation is not one-to-one, it's not one-to-one, then how are we going to determine the joint PDF of the new random vector, the new bivariate random vector of random variables u and v? As again, the same process, we're going to determine our script A here. So script A is the set of all xy. Oh no, I'm going to replace my pen. Excuse me for a while. Okay, so the same process. Determine our script A. So script A will be the set of all ordered pair xy such that the joint PDF is positive. Ito, pareho lang. But we're going to get the partition of this script A. Say we have the set a sub 0, a sub 1 up to a sub k, finite, finite partition of script A. With these following properties, the set a sub 0, which will be empty, which may be empty, satisfies that the probability that the ordered pair xy is an element of a sub 0 will be equal to 0. And then we have the transformation u will be equal to g sub 1 of xy, and then v will be equal to g sub 2 of xy, will be one-to-one transformation from the set a sub I onto script B. That is for each I 1 up to k. So meron na tayong one-to-one transformation from these partitions, subsets of our partition, a sub I onto script B. Then for each I, we will be able to get or determine the inverse function from script B to a sub I. And we denote that x here now by h sub 1 I of uv, and then y is h sub 2 I of uv. I still from 1 up to k. So we can now get the inverse, hence the joint PDF of our new random vector of random variables uv will be equal to this finite, countable summation of the product. Okay, the product of the joint PDF of x and y that will be evaluated on the inverse function h sub 1i, h sub 2i times the absolute value of the Jacobian of our transformation on the Jacobian of the transformation from a sub I to script B. I from 1 up to k now. Okay, so this is now the formula if we have a function or a transformation that is not one-to-one. So let's have an example to illustrate this before going to the next section of chapter 4. So distribution of the ratio of normal variables. Let x and y be independent normal distribution, standard normal distribution. Okay, we call it standard because it does not depend on any of the parameters, because we fix our mean to be 0 and the variance to be equal to 1. Then consider the transformation u will be equal to x over y, and then v to be equal to the absolute value of y. Okay, so letter A, find the joint distribution of x and y. Find the joint distribution of u and v. Then find the marginal distribution of u. Okay, based on the previous example, we can find the joint distribution of x and y. So from the previous example, from example 4.3.4. So the joint distribution of x and y here would be equal to 1 over 2 pi, the exponential function, okay, of negative x squared over 2 exponential function of negative y squared over 2. And then we have here. So you need to write the support. Oh no. The support for this joint PDF. Dito ko lang isulat yung x, comma, y, positive infinity. Okay? What is our transformation? So, yung transformation natin, we have this random variable u is equal to x over y, and then v is equal to the absolute value of y. Okay, note that this transformation is not one-to-one, since we have here the points x, y, and or the ordered pair x, y, and the ordered pair negative x and negative y are both mapped into the same ordered pair uv point. Okay, so it's not one-to-one function. So this time we're going to partition uh, our script A. But first here, our script A here would be the set of all ordered pair x, y such that the joint, okay, in joint would be positive. And then our script B here would be the set of all ordered pair uv such that the u from negative infinity to positive infinity, and then our v here is positive because it's absolute value of y. That will be positive. And then we let script A here be the union of this. We have a partition. We have A sub 0, union A sub 1, and then union A sub 2 here. Okay? Such that the intersection of these sets will be equal to empty. Okay, so we let A sub 1 here be the set of all ordered pair xy such that y is positive. And then we let A sub 2 here be the set of all ordered pair xy such that y here is negative. Then A sub 0, the set of all ordered pair xy such that y will be equal to 0. So the A sub 1, A sub 2, A0, A sub 1 form the partition for script A. And this is actually equal to lahat naman. This is for all x and y greater than infinity but less than infinity. Therefore, your script A will just be equal to r square. And then the probability that xy is an element of A sub 0, that's the probability that y will be equal to 0, will be 0, and either for either A1 and A2, if we have this ordered pair xy element of A sub I, then our v here, which is the absolute value of y, would be positive. Okay, so we have here v is equal to the absolute value of y, u is equal to x over y. Can be any real number since x can be any real number. So for considering now for y to be greater than 0, that is in the set A sub 1. So mo na itong transformation na to. We have u is equal to x over y, and then v would be equal to, we have the absolute value of y positive. The absolute value of y will be equal to y. So this would imply now that our x here, or a y muna, will be equal to v. So our x would be equal to u times v. So in this case, for the set A sub 1, Pwede naman yan biconditional statement. This biconditional statement implies now that the our transformation is a one-to-one transformation from A sub 1 onto script B. Script B. Okay? So we can now determine the inverse function for this particular set. Ito yung kanyang inverse function, x as a function of uv, then y as a function of uv. And this now would imply that the partial derivative, right, and the partial derivative of x with respect to u would be equal to v, partial derivative of x with respect to v will be equal to u, partial derivative of y with respect to u, we have here 0, partial derivative of y with respect to v, we have 1. And this would further imply that the Jacobian of our transformation, we have v times 1 minus u times 0, so the answer will be equal to p. Okay lang? Diretso? That's our... Uh, and then, for the next case, when we consider y here to be less than 0, that is in the set a sub 2. So the transformation now, we have u is still equal to x over y, and then this time our v would be equal to negative y. Because v is the absolute value of y. So if y is less than 0, that would be the negative of y. So if and only if, again, we have here x to be equal to the negative uv, and then y would be equal to the negative v. Again, for any uv, there exists uh, only one ordered pair xy, such that u is equal to x over y and then v is equal to y. So there exists a one-to-one transformation from from A2 to script P. Hence, the inverse function exists. Ito yung x natin as a function of uv, and then y is a function of u and v. Then we can now proceed by determining the Jacobian of our transformation. So the partial derivative of x with respect to u would be equal to negative v. Partial derivative of x with respect to v, we have negative u. Partial derivative of y with respect to u, we have here 0. Partial derivative of y with respect to v, the answer is negative 1. So, j sub 1 pala yan. No? Okay, j sub 2, the Jacobian of our transformation. So this would be equal to still positive v pa rin. Okay, thus, using our formula now, the joint distribution of u and v, PDF, no, would be equal to the finite or countable summation of the, so yung countable summation natin, sabihin na lang natin, we have here the f of x, y. Okay, yung first consideration natin, we have here u, v, and then we have v times the absolute value of j1 plus the f of x, y. In this case, we have negative u, v, and then negative v, and then the absolute value of j sub 2. So we have here 1 over 2 pi, the exponential function of negative uv quantity square over 2 times v, absolute value of v, and then plus 1 over 2 pi, the exponential function of the negative uv quantity square over 2. Sorry. Ano eh? Nak, yan mo nak. Kulang pa. Okay, so kulang pa pala tayo. Kaya pala. Exponential function of the negative of v square over 2 times v. Absolute value of v is v plus yung second term natin 1 over 2 pi exponential function negative uv quantity square over 2. Okay, the exponential function of the negative of negative v quantity square over 2 times v again. Okay? So in this case, yung u and v natin, okay, simplify na lang natin to, ang part na to. So from the first term, we have two exponential functions. Pwede natin itong ma-add. The same actually expressions to, because in the second term, the square of the negative uv will just be equal to the square of uv, quantity uv, and the square of negative v will also be equal to v square. Okay? V square. So, pwede na lang yan siya ma-add. No? So, we have 2 over 2 pi. Then we have here the exponential function of negative uv quantity square and then minus. Okay? Minus or plus, no? Plus the negative. Pwede na yun. Minus na lang. Diretso na lang. V square over 2. And then, dito yung V natin. Yung part na yan. Okay, so, we have infinity. So, we have here U, V, positive infinity. So, we have here V over pi, the exponential function. So, we have the negative of U square plus 1 times V square over 2. Okay, so that's the answer for letter B problem. That's the joint PDF of the new random vector random variables UV. Letter C problem. What about the marginal distribution of U? So for letter C problem, now the joints, rather the marginal distribution of U would be equal to the integral. Then we have here the joints you have here dv. Okay. Sorry. Hindi ko pala na-check na nakalimutan ko pala. I'm very sorry for this. May restriction tayo sa V. So, U natin, but our V, kasi ang V is the absolute value of Y. Ito, hindi ko nakita. So, we have here, U, ang V natin, set of all positive real numbers. Okay, so indicator function natin sa V, that would be 0 to infinity on the set 0 to infinity. So yung ang ating limits of integration will be from 0, pwede naman sa, lagay muna natin negative infinity to positive infinity. So that would be equal to, you apply. So we have here v over pi, exponential function, v square over 2. Yung indicator function natin sa on v, that is 0 to positive infinity, so this would be 0 to positive infinity. So we have here dv, well, for u, ganun pa rin. Okay, so we have here over 2. Okay, let's apply change of variable. Say we let z here to be equal to v square. So dz will be equal to 2v dv. So meron tayong v dv dyan. So dz over 2v dv. Hence, we can have now 1 over 2 pi. You have the exponential function negative quantity u square plus 1. Okay. Ang v natin, that is z. V square is z over 2. Okay. That is over 2 here. And then yung VDZ natin, that is DZ over 2. Nandito na yung 2 niya. So, nandito yung DZ. Okay? Still, we have here from 0 to positive infinity. Okay, so if we're going to look at the integrand, the integrand of our integral, we can see or notice that we have the kernel of an exponential distribution. Diba ano pala yung exponential? We have 1 over beta e to the negative x over beta. Parang ganun yung kanyang probability density function. So we have here e to the negative z over, that would be your expression. So in other words, we have here, ito makita natin na we have the kernel of an exponential distribution with parameter. Say, yung beta natin, yung parameter beta natin will be equal to 2 over u square plus 1. Therefore, kernel man yan siya. So, the appropriate expression that we're going to multiply at the same time divide to be able to get the PDF of our exponential distribution, then we have beta over beta. So beta over beta. So yung beta natin, that is 2 over u square plus 1 over 2 pi. Answer niyan siya. Kasi yung result niyan, yung 1 over beta exponential, kasi ito yung beta. At ang itong beta nga part, ito parang yung beta. That's your beta. The integral of 1 over beta and then e to the negative z over beta dz. So, using the property of a PDF, that will actually equal to 1. So, yan yung answer natin. u square plus 1. Or we simply have 1 over pi, okay, 1 over pi times 1 over 1 plus u square. Kalimutan ko. Okay, so this is now the marginal probability distribution function um, for u. And you can verify that this u, random variable u, has a Cauchy distribution. Standard, no? Standard distribution pa rin yan. 0 and 1. 0, 1. Okay, so I think we're done with the bivariate transformation, in which we consider a one-to-one. If we have a one-to-one onto transformation from script A to script B, I gave it two examples, and then we have also an illustration in which uh, no, we have a transformation that is not one-to-one. Okay, that's for the bivariate transformation. Later in the next in the latter sections, we're going to deal with multivariate distributions. And bivariate lang naman, dalawa. Any questions or clarifications?
None, sir.
Okay, so we're done with with section 3, and then chapter 4, not chapter 4, section 4 is a reading assignment. Okay, I think nabasa nyo na to. Nabasa nyo na ba to? Chapter 4? Section 4? Let's proceed now to section 5, the covariance and correlation. Wala na. Okay, hanap tayo. Covariance and correlation. Okay, yan na. Okay, so we are now on section 5 of chapter 4, covariance and correlation. These are actually two numerical measures of the strength of a relationship between two random variables. So for our notations that we're going to use here, the mean of x can be expressed as mu sub x. The mean of y, expectation of y, can be expressed as mu sub y. And then the variance of x here, okay, sigma sub x square. And the variance of y, sigma sub y square. Okay, and then we will assume that the variance of x and y, they are positive and finite. So definition 4.5.9, the covariance of x and y is the number defined by, okay, this is our notation, the cov of x and y. This is actually equal to the expectation of the product of x minus the mean of x and y minus the mean of y. And then the correlation of x and y is the number defined by this Greek letter rho sub xy. It is equal to this fractional expression, which is the covariance of x and y for our numerator, divided by the product of these standard deviation of x and y in our denominator. And then the value rho of xy is also called the correlation coefficient. Not only the correlation of x and y, is also called the correlation coefficient. With regards to this two definition, we have the following remarks. If we have large values of x, tend to observe with large values of y, and then small values of x with small values of y, then the covariance of x and y will be positive. If the large values of x tend to observe with small values of y, and then the small values of x with large values of y, then the covariance uh, of x and y will be negative. So for the covariance, the sign is very important. It gives us information regarding the relationship between x and y. That means if we have a positive result for the covariance, then we have a positive relationship between x and y. X and y are, later on, we'll see that they are positively correlated. And then if we have a negative value for the covariance of x and y, that means that there's a negative relationship between x and y. And this would further imply that we have a negative, uh, x and y are negatively correlated. Okay, so sa covariance, titingnan lang natin yung sign niya. It says here, we can find, no, we can get a value such as 3, but it will not give us information about the strength of the relationship. So on the other hand, yung correlation value is always between -1 and 1. So with value -1 and +1, indicating that we have a perfect linear relationship between x and y. So kung -1 yung value ng correlation coefficient, we have a perfect negative linear relationship between x and y. If we have rho of xy to be equal to 1, then we still have a perfect positive linear relationship between x and y. Okay, theorem 4.5.3, for any random variables x and y, the covariance of x and y will be just equal to the expectation of the product xy minus the product of the mean of x and the mean of y. And we have here the proof. The first equality here is by definition. And then the second equality, we expand the product inside the expectation operator. And then the third equality here, we apply. Now we apply the expectation operator, knowing that the random variables here are x and y. The mean of x and the mean of y, these are all constants. So yan yung result for equality number 3. Equality number 4, since we assume that the mean of y is equal to mu of y and the mean of x is the mu of x, you can further simplify to be able to get the last equality. Okay, so the proof is so easy. Let's proceed to this example now. Correlation number 1. Okay, let the joint PDF of this bivariate random vector xy be f of xy will be equal to 1. X between 0 and 1 exclusive, and then y between x that is greater than x but less than x plus 1. We can see that in figure 4.5.1. So on the horizontal axis, we have the x axis or the values for x, and then on the vertical line or vertical axis, we have the values for y. So yung value ng x natin is from 0 to 1. So when x is 0, the value of y will be equal to 0. Between. And then ang value ng y is between 0 to x plus 1. So 0 to 1. Kaya ito yung another value. When the value of x is 0, we have two possible values for y. It's either x equals 0 and then x equals to x plus 1. Y is equal to x plus 1. Now we have that. When the value of x is 1, the value of y will also be equal to 1. Klaro naman yan sa figure natin here. 1. And then x plus 1 also for the value of y. So we have here 2. We have this order pair 1, 2, 1, 1. 0, 0. Okay, so it says here, that the marginal distribution, okay, sabi dyan that the marginal distribution of x is a uniform 0, 1. Okay, let's try to verify this. Meron naman tayong joint. Madali naman pag-determine ng marginal using the formula. So we have here the marginal distribution of x would be equal to the integral of the uh, negative infinity to positive infinity. We have the joint. Okay, we have here dy. Okay, or x, nandito naman yung x natin, and then y, x plus 1. Okay, so dy tayo. So kung dy tayo, we have 1. So, tara lang tayo. We have x to the x plus 1. Yung f of xy natin, 1 naman lang yan siya. So, meron tayong dy. Okay? And then our x here. So, we have y. So, we have x plus 1 minus x. So, we have 1. Okay? So, this implies that the random variable x has a uniform distribution. So parang 1, okay, 1 over A. Ang A natin dyan, ang B natin is 1, A is 0. Okay, so we have that. So ano yung mean? The mean of x, which is equal to mu sub x. Clearly, the answer for that would be 1 plus 0 over 2. Okay, so we have 1/2. The variance of x, that is sigma square x here. Okay, we have already the formula. It is 1 minus 0 quantity square over 12. 1 over 12. So we have verified this uniform. This is also verified. This also verified. Okay. What about the marginal PDF of y? Okay, for the marginal PDF of y, we have here actually ano tawag nito? Kalimutan ko. Paano nga to? Yung pagkasulat nito is equal to y. And then we have here 2 minus y. Okay, so you try to verify this, no? Okay, we have that. Verify those possible values. Okay, so say for example, verify natin yan. What about the mean of y here? Will be equal to 1. So yung mean of y is mu sub y. Okay, that's by definition. We have the integral from negative infinity to positive infinity. We have y times the marginal distribution of y. dy. Pwede naman natin yan siya but we can using our marginal distribution of y, then we have here from 0 to 1, we have here y, and then the PDF for that is equal to y dy plus, okay, from 1 to 2, we have y, and then we have 2 minus y dy from 1 to 2. Then if we're going to evaluate this, we have here y squared, so we have y cubed over 3, evaluated from 0 to 1. Plus, we have 2y, and then y squared, 2y squared over 2, so y squared na lang yan. and the negative y squared, so we have y cubed over 3 evaluated from 1 to 2. So we have here 1 third. Okay, klaro naman yan. Minus 0 plus 4. Okay, 4 minus 8 over 3 minus 1 minus minus or plus 1 third. Okay, so if we're going to simplify here, the answer is equal to 1. Ayan, verify na yan. So that's what about the variance of y? So for the variance of y, gagamitin natin ito. The variance ng y is equal to the mean of y squared minus uh, minus the square of the mean of y. Meron na tayong mean of y. Ito na lang kulang. So evaluate this. Ganun din. Okay, parang pareho lang yan. Y squared times dy. And then you follow the same steps. You would be able to get the value for this, which is equal to 7 over 6. Therefore, the variance of y now would be equal to 7 over 6 minus 1. We have here 1 over 6. And that would be equal to variance of y. Okay? Now we're going to determine the covariance of x and y. Okay, the covariance of x and y using our formula, that's actually the mean. The mean of xy minus the mean of x times the mean of y. Eh, di pa man natin pa yan na-solve pala yung mean of xy. Dito yung mean of xy. Well, the mean of xy now would be equal to. Okay, so we have the joint PDF for x and y. So we have here the double integral. Okay, the double integral from negative infinity to positive infinity, negative infinity, positive infinity. Then we have our joint PDF, dy dx. Since the value of x is between 0 and 1 exclusive, so for dx here, 0 to 1. Diretso na, wala na tayong indicator function dyan. Diretso na sa PDF. While for dy, dy y greater than x, but less than x plus 1. So we have here the limits of integration here would be x to x plus 1. And madali naman to i-integrate. Integrate with respect to y, so we have y squared over 2 and evaluate. Therefore, the answer for the mean of the product xy will be equal to 7 over 12. So to solve now the covariance function of x and y, the covariance of x and y. So this is for the mean of xy, this is for the mean of x, this is for the mean of y. And therefore, the answer is equal to 1 over 12. And then computing for the correlation of x and y, we have the covariance of x and y over the product of the standard deviations. So 1 over 12, we already computed for the variances of x and y, so we can compute for the standard deviations. So we have that. If we're going to express this in decimal, this is equal to 0.707. Okay, so I will going to use that value in the next examples that we have. Okay, so this is just an illustration in computing the covariance of x and y as well as the correlation of x and y, or the correlation coefficient. Any questions or clarifications? Madali lang, di ba? So let's proceed, I think. Let's going to proceed. Theorem 4.5.5, if x and y are independent random variables, then the covariance of x and y will be 0 and the correlation coefficient will also be equal to 0. Okay, this is not a biconditional statement. Uh, so pag x and y independent, then it would imply that the covariance of x and y is 0, as well as the correlation coefficient would be 0. Okay, the proof is very easy. You can follow that one. The covariance of x and y, that's by definition for the first equality. Second equality, using the independence assumption, so we get 0. Using the formula for the correlation coefficient, the covariance is 0, so the correlation coefficient would be 0. Okay, so uh, when we say the covariance equal to the correlation coefficient equal to 0, in a sense, it indicates that there's no relationship between x and y. Okay, so in theorem 4.5.5, it does not say that if the covariance of x and y is 0, then x and y are independent. So the converse is not necessarily true. Okay, now the covariance and correlation measure only a particular kind of linear relationship, and that will be discussed further in theorem 4.5.7. But let's going to look at the role, or say, the function, or I say the rule of the covariance function, especially in the variation in the sums of the random variables. Okay, we know, no, we know that if uh, if x and y are positively correlated, then the covariance function is a positive value, positive real number. If x and y are negatively correlated, then the covariance function of x, or the covariance of x and y, has a negative value. So let's just try to look uh, the role of this covariance function when we have sums of random variables. So if x and y are two random variables and a and b are any constants, then we have the variance of ax plus by will be equal to a square variance of x plus b square variance of y plus 2ab, then the covariance of x and y. This is actually a generalization of theorem 2.3.4. Okay, in which in this theorem here, we have the variance of ax plus b is equal to a square times the variance, okay, the variance of x. Ganun man lang yan. If x and y are independent random variables, then the variance of ax plus by will just be equal to a square plus the variance of x plus b square times the variance of y. By the way, uh, ang sa before this theorem, we have there a paragraph that states that the variation of the sums of random variables here. So when we have a sum of random variables, though we can have a numerical coefficient here, a coefficient of a and b between on x and then b for y. If we consider the sum of two random variables x and y, we just consider a here to be equal to 1, and then b will be equal to 1. Then we have now the variance of the sum of x plus y. Okay, so general lang tayo. Lagyan natin ng ng coefficient a and b, constants, no? A and b. Okay, so I think this is the proof is so easy. The mean of this expression ax plus by. Okay, we have here, we have that notation. And then first step here, we're applying the definition of the variance of ax plus by. That is, yung variance ng x natin will be equal to the expectation of x minus the mean of x quantity square. Kaya lang, yan yung ginamit natin. General lang tayo dito. So, ito yung random variable natin. We have a linear combination of ax plus by. We know already the mean of this ax plus by. Simplify. This first equality. Second equality here, we simply have we group as well, group having a common term, a common factor, and then we factor. Applying factoring by grouping. And then after that, we apply or we expand. No, we expand what is inside the grouping symbol here, the parenthesis. We square it, so we expand. Then the third equality here, or the fourth equality rather, we apply the property of the expectation operator. Okay, the expectation operator. So we have that, and therefore we arrive at that uh, last equality that proves our theorem. So if x and y are independent, obviously the covariance will be 0. And the second equality is able to get the second equality in our proof. Okay, so before we end, uh, let me continue. Bago din yung theorem 4.5.7. So kung meron tayong sum, uh, no, we're going to be able to determine the variance of the sum of two random variables. So that means na if x and y are positively correlated, then the variation in the sum of x and y, we consider here a to be 0, a to be 1, and then b to be 1. That's why we have x plus y. The variance of the sum, ax plus by, so ang a is 1, b is 1. So the variance of x plus y will just be equal to the variance of x plus the variance of y according to the theorem, plus 2ab, the covariance, 2 times the covariance of x and y. So that means the variation of x, the sum of x and y, would be greater than the sum of the variations in x and y. Okay, may additional tayong terms dito eh. Yan. But if x and y are positively correlated, it means now that the variation of the sum of x plus y is lesser, no, than the sum of the variations of x and y. Okay, so that's the role of our covariance function here. Before we go, do you have any questions or clarifications? I think yung present ngayon, konti lang. Why is it, no? You're depending on the recording. Kaya siguro hindi na lang kayo pumasok. Okay, so we have Ray Cuenca, Dina, LJ, Mary Jean. We have Kim, Marivic, Christine, Sharon May. Kanina nakita ko si Noli. Nakita ko din si Kier. Si Kier. Who else? Who else yung present na nakita niya? Guys, are you there?
Yes, sir.
Oh.
Marag sila lang, sir. Ako nakita ko.
Yes, sir.
Okay, so I'm going to continue my discussion. I think no questions or clarifications regarding this topic.
Wala na, sir.
Wala na. Okay, so that's all for this afternoon, and class dismiss. I'm going to stop now the recording.
Thank you,
Thank you,
sir.
sir. Thank you.
So bye.
Bye, sir.
Bye, sir.
Bye.